Asieh Golozar is going to walk you through creating cohort definitions.
Hi everyone, my name is Asieh Golozar and this is going to work, yes, okay. I am going to tell you a little bit about creating cohort definitions. Just an overview of what is a cohort, how do we define a cohort, what is it when we say cohort and OHDSI, the definition. And then we're going to try to create two cohorts together. One, I don't know why this computer, it's the cable, it's not me. We're going to do two, we're going to create a cohort of new users of lisinopril and also a cohort of acute myocardial events in Atlas. So, just to give you a little picture of this is just like a caricature of a patient journey. Each event, every time something happens to a patient, there's these traffic cameras. There is a picture, right? Like a diagnosis, a disease diagnosis happens, a patient gets a treatment, then there is adverse events of the treatment or some other outcome. So think about it as these traffic camera, each event is like a snapshot. It's what we see at each time is an incomplete picture of an entire patient journey. And we see it for patient 1, patient 2, patient 3, and so on and so forth, whoever we have. What we want to do is to make sense of these incomplete picture, getting some evidence from the patient journey. So this can be, the reason we're here is to create evidence, right? When we're talking about evidence is, can we characterize who are these patients? Who are my patients with acute myocardial infarction? What is the incidence of specific events for them? Can we look into a causal effect? Can I do comparative effectiveness using, looking at new users of drug A versus drug B to come up with an inference? Or at a patient level, what will happen to my patient? This is what we want to generally get. That's why we're here. We want to get this from the data. So an input of all of them, if I want to characterize my patients, I need to know a cohort. I need to have a cohort, a target cohort of my patients, acute MI, for example. I also want to look into another, we also want to look at another one, I don't know, hypertension. I want to have a comparator group, making it up. I want to look into the baseline summary of the outcomes, which patients are experiencing that specific outcomes. I work a lot in oncology, so I'm going to switch to oncology examples. It comes easier for me. Which lung cancer patients will experience death? That's an outcome. I need to create a cohort. Which will experience progression? Progression, that would be an outcome. Treatment initiation. I want to describe incidence of outcomes. For that, I still need to be able to define my cohort for which I would like to have an incidence of specific outcomes, so outcome cohorts, target cohorts. And sometimes I want to see the incidence across different cohorts, target cohort and comparator cohort. For population level effect estimation, I still need cohorts. And when we look into patient level prediction, again, everything we do is based on cohorts. You heard about it from Patrick yesterday. This is the foundation of what we do. So we saw this slide again yesterday. So phenotype is what we do, and when we create cohort, we call it phenotyping. Is a specification of an observable, potentially changing state of an organism. So there are two approaches to develop phenotyping when we talk about it. One is going through rule-based phenotyping. This is what we're going to focus on today. With rule-based, you guys are pretty familiar with that. I'm going to say that my patients with hypertension are defined as those who have had a diagnosis of hypertension and did not have a prior condition of diagnosis prior to that, and a set of other things we're going to talk about. So rules that we're going to apply. There's another one that's called probabilistic phenotyping. That's not the topic of today. With rule-based phenotyping, we use Atlas, and we're going to do it today, or we can use SQL. So we heard about this again yesterday. We saw all the Legos. So the Legos are the bricks for phenotyping. Just think about different ones. Each color represent different things, condition, drugs, procedures, measurement. We use them, we put them together based on a schema, like structure. So you can actually draw the structure of how you want to build your castle. Then you start putting the Legos together, and that's how we create the cohort. So there are a lot of work that has been done on phenotyping, and this is just an example that's showing you that usually, like just using when we want to create a cohort, for example, a specific condition, just looking at conditions alone would not give you a comprehensive and like most reliable cohort. Usually a combination of different types of data like conditions and treatment and procedure would give you like this subset of a complete subset of patients. Depending on the conditions, you see like the diagrams are like overlapping higher or much or less. So in OHDSI, we define cohort as a set of persons who satisfy one or more inclusion criteria during a period of time. A cohort era is a continuous period during which the patients have satisfied those criteria, the inclusion criteria. And what we call the cohort definition is how we do that, how we put these Legos together to get that. So that specific definition has consequences, right? A person can belong to multiple cohorts. So a person that has hypertension and later on will be put, like initiate like, I don't know, like drug A and later on will experience MI. They can belong to a cohort of MI, they can belong to a cohort of lisinopril, and they can also belong to a cohort of hypertension as long as they satisfy the inclusion criteria. They can actually belong to the same cohort at the same time. That's okay. One person cannot belong to the same cohort multiple times during the same period, right? So once in, you will be in, you have to get out to be able to get in again. It's completely normal to have a cohort with zero observation, with no person in it. Because you're putting these Legos together, you want to have like this set of criteria to match. It's okay if you get zero observation. And most importantly, a code set is not a cohort, right? You need to have the logic, that whole sketch of how to use that code set to get to that. So generally, and that's technically what I do when I get to create a cohort, I start with a blank piece of paper and a bunch of colorful pens and markers, because that's just fascinating, to start drawing it. Like, it's like creating the logic. What is it that we want to do? And then like I move on to Atlas. So if you think about like the anatomy of a cohort definition, everything starts with an entry event. What we call in general studies index date. So the cohort entry event would be the index date. And we build the cohort, we anchor all the events, all our inclusion criteria around our cohort entry event. So we can have a set of inclusion criteria with a temporal logic around our cohort entry event. That can be existence of an observation, existence of a condition. It can be lack of existence, so like a patient with no prior hypertension. So inclusion criteria can be zero, or presence or absence of an event. So when we want to do that, like we have to, and then like we said that like these patients need to be followed up throughout time, and then we have to define what are the criteria when they exit the cohort. So the cohort exit criteria. So these three pieces will define your cohort. So when we like start putting it together, a set of questions that we have to ask. So want to do a study. The first question is that what is my initial event for cohort entry? What is the index date? So that's the most important thing. Like new users of lisinopril with no prior hypertension. Is it hypertension, or with prior hypertension? Do I want to start as like the index date as use of lisinopril or having hypertension? That's the most important part that you gotta fix. You can get the same number, but that's a different inference. You get completely different results. So define your cohort entry events, then start pointing out what are the inclusion criteria that you have to put together with what temporal logic, and what would define the cohort exit event. So I want, for example, my patients to be in the cohort until they discontinue lisinopril or something else. Like, I don't care. Like, I want them to be there. And once they're exposed, they're always exposed. It depends on the question or the study that you want to conduct. So as we said, like for defining cohort entry events, we said like these events are recorded timestamp observations like within a patient journey. So that can be a drug exposure, new use of lisinopril. It can be a condition, hypertension. It can be a measurement, having a, I don't know, like what can I say? Having a tumor stage 3 of lung cancer. So it can be a measure, or it can be a visit. I want to look into inpatient visits. So the cohort index date is the event start date. So that's how we look at it. And the way we build these are, we look into the domains. Are we interested in condition, drugs, and all that? We create the concept sets. And sometimes, like if there are any specific domain-specific attributes that are required, for example, you're looking into measurement, you want the measurement to have specific value. You use all that to create the concept set and then put them together. What's very important to note is that we want to define cohorts by existence of an observation, what we can see. We know that like lack of hypertension, what does that mean? Did it happen? Did it not happen? Because I can see a snapshot, right? So always define your cohort by existence of an observation. When we're looking at age if you want to look into like age of a patient, do not use it as an index date, because the problem is that you do not define. Sorry, I missed. Because the index dates will be anchored by age, right? So then like it will change constantly. If you want to look into calendar date, be careful about observation bias. So because again, these are snapshots. You might not see an event during a snapshot. Try to look into time frames if you want to look into that. Once you define your cohort entry event, you want to look into inclusion or exclusion criteria. So what are the qualifying events that I want to have for a patient to be included into my cohort, right? They need to be adults. They need to have no prior other hypertension. They need to have at least this many observation period and all that. Write it down, and then again use the same thing. Which domains do you have to use? What specific attributes, and how you want to build it? The temporal logic around within what time frame from your index or cohort entry event you want to look for the absence or presence of a specific event. Then put it together. So in order to avoid any confusion, we call everything an inclusion criteria. So we don't do exclusion and inclusion. Exclusion is pretty much like having zero of a specific event. I keep saying the temporal logic, do not assume that a temporal logic exists. You have to create it. That's very, very important. And also, there's always a difference, that's what we're going to go through together, but there's a difference between first time in a patient history with more than 365 days of prior observation and no observation in at least 365 days. So one of them is saying that within the past year, I didn't see anything. The other one is it's the first time it's happening, but this patient has 365 days of observation. So subtle difference, but it makes a lot of difference when you want to create your cohort and look into the patients. And finally, you have to define your cohort exit date, right? So at what point that specific patient will no longer be qualified to be in your cohort, right? It can be end of an observation period. It can be a fixed time interval in a sequence of related observations. So it can be end of persistence of a drug exposure, right? So you want your patient to be in your cohort while they're on that specific drug or they're exposed to the drug, or it can be censoring observation. So that specific cohort exit strategy will tell you, it has an impact on whether a patient can belong to your cohort multiple times or not, right? So if you have your cohort exit strategy end of observation time, the patient will be in your cohort until the observation time ends, right? But if you have your cohort exit strategy of like 1 day after the occurrence of the event, if the event recurs, that patient can potentially belong to your cohort as long as you're not looking at the first time it's happening to the patient. Always try to define your cohort exit strategy, even if you're not trying to use it. Do not, patient exit. The exit strategy is not censoring, so let's not confuse it. Censoring time, so that's like the censoring can be dealt in the analysis, but any other things that you want the patient to be exited, it has to be clearly defined here. And the other important thing is that time at risk is not censoring, is not an exit. So do not mistake time at risk with cohort exit event. So again, time at risk is something that you will deal with in the analysis and you can study, but this is completely different. So we talked about the questions that we want to answer when we're creating it. But then we have to create it. We also said that like in order to create the cohorts, we need the specific domains that we want to look at, concept sets that we put like specific concepts in, what domain-specific attributes, and temporal logics to put this all together. So to start with, we have to do the concept set, and I don't know whether this was covered, so I just do like a very, okay, great. So there was a very, very good workshop last year, which badged a lot of folks with the capability to create concept sets. I think the material is available. Highly recommend, like for those of you who want to like get deeper into creating concept sets and like what to look at to actually go through that. I'm not going to spend a lot of time, just give like one sort of like overall picture of. So the concept set is a logical expression that represents a list of concepts within the OHDSI standardized vocabulary that encompass a clinical entity. I want to look into hypertension, right? So what specific concepts or what specific which concept specifically or what set of concepts would represent that idea, hypertension, right? There are optional operators that you can use when you use that, right? So sometimes like you're looking at specific concept sets and you look within the hierarchy, you see this, they're descendant of that concept sets that you do not want to include, right? So can be that like within hypertension or MI, you can have like a history of MI as a descendant or an old MI. I don't want this to be a part of that because I want to look at like anything new, you can exclude them. Always look into the hierarchy. Make sure that like whether you want to include the descendant or not, and which set of descendant you want to include. And also you can always look into the mapped concept if you want to make sure that specific, like all the mapped concepts are there. Yeah.
Specifically about the exclude, does exclude just remove things from the concept set? So like if you're doing, angioedema, but you want to remove ACE inhibitor angioedema, it just removes those codes? Or does exclude say, if you have this code, the whole person is out?
No. All the concept codes, that version 1. Yeah. Yeah. So if you're thinking about like have like the whole mindset of like how we do observational studies, concept sets is literally a standardized computer executable equivalent to what we often call a code list, right? So if like you've seen like these papers, it's like, oh, they're like these set of ICD-10 codes were used. And like ICD-10 and ICD-9 codes were used for hypertension. So when we put them together with those like logic of like include and exclude and all of that, this is called a concept sets. And then, so we can actually create that using Atlas. This is something that we're going to do together. So we're just going to do it live, not going to spend time. Also, your friend can make it. They can copy it, save it as a JSON file, and send it to you, so you would just load it up. So there are different ways to do that. We don't need to do it all the time. So when we're looking into concept, again, like how are we going to do it? There are two ways to look and identify all the important and necessary concepts that represent that clinical entity. The first one is Atlas. So this is based on so I do it like you can look into the Atlas. Your Atlas instance will look into the data and will give you an idea of those specific concepts that you can pick up, right? If you don't have a specific vocabulary, you might not see that. So it's a face validity of what is in your specific instance, right? So a very good example is that I'm going to use an oncology example. So there are new vocabularies in the oncology that you would use to identify specific conditions like non-small cell lung cancer. If your specific data set is not using those vocabularies and you do not have it, you will never be able to identify it if you use Atlas. So that's something to remember, especially when we're talking about doing studies in a network and together. Is it good enough? Should I look at anything else? And you can do it through a couple of times. What I do personally, I look through the hierarchy, I go up and down, I go to Athena, come back. There is another very good tool on the left side, which there's a version 2 that was introduced yesterday. Highly recommend that. So we can look into the concept set. We look at the standard concept. We can look into the hierarchy. And we can decide, is it something that we want? Is it something that we don't want? And we can put it together. There is a recommender system called Phoebe. Phoebe is based on the records that comes from the records across all different databases. So it's not your specific data, right? So that gives you the capability, the possibility to look at what can be a good representative, or what are the specific concepts that I should include in my concept sets that might not exist in my data. So much better. And when you're looking into Phoebe, you can look into the included concept, check into those who are not included, look into the parents. But what's important about Phoebe is that it's a concept recommender. So you go through all the recommendation and you make a decision which one to include or not. Anna introduced Phoebe version 2.0. It's more powerful than this one, and highly recommend. I played around with it. I didn't see it in the Atlas instance of the tutorial, so unfortunately, we can't show it unless we switch to the demo Atlas. That one has it. So, but play with it. It's really cool. It gives you a lot of options, and it's a part of Atlas now. So it's used to be a whole different setup. So we got to go back and forth. It's just amazing at the moment. So we were talking about the phenotyping. I told you how we put them together. We get the concepts, we create the cohort, and we have a definition. But there's always the question, is my definition good enough or not? This is something that Gotham is going to tell you a lot about. But in terms of the process, I'm just going to introduce it quickly. It's an iterative process. I create my concept. And then I use these concepts to define my cohort using the logic. What is my initial events? What are my inclusion criteria? What is the cohort exit strategy? I create a cohort. While I'm doing that, I might realize that I need, the concept sets are not comprehensive. There's always a feedback loop. I go back. Let's update the concept set. I forgot something. I forgot an inclusion criteria. I need to create a concept. Or I need a specific concept set, or I need a specific concept to add to my concept set. So we have to always do these, we usually do that. And later on, once we created the cohort, we go through some sort of cohort validity assessment. This is through cohort diagnostics that you guys are gonna hear more about. But again, through that, we identify a lot of potential concept sets, or ways that we have to just tweak our cohort. So there's also feedback loop from what we get from cohort diagnostics, going to update the concept set. Oh, I forgot to add that. Seems like if there's an important concept set, there's a lot of events, observation there, I should add it, I have to go update that. Or it looks like this one is not right. Same feedback loop to the cohort definition. This is for the next part, so I'm not gonna spend a lot of time with that. So we usually do these checks at least twice, after concept set, cohort creation, making sure like we're not missing anything, cohort diagnostic, review of cohort diagnostic, check another round to have a good feeling that's is representing what we want to represent. All the criteria will be discussed, and Gotham will walk you through that. I'm going to pause here for a second to see if there are any questions. Yes?
If we have multiple cohorts, so that the cohort diagnostics going to show different ones, or one that could contain all cohorts?
It's all that one contain all cohorts. You will see that. Yeah. Anything
you need
on
to work with a cohort that an instance of cohort diagnostics that has multiple cohorts. So
And this is independent of the data. This is specific for the cohort, not looking at the data, like to see how are we doing the cohort, whether we're doing it right or wrong. But
yeah, so cohort diagnostics is a different set of tool that I will talk about. What it does is it reports the summary of the people that were identified in your data source. So that's the next step. This is more generic. This is just defining the rules that will be applied on your data source.
yeah.
and those rules, I missed that point when you mentioned vocabulary. So I've worked with phonetics, and it depends on the ICD-10, right? So here, what is the standard? Like, is it the Atlas?
The standard rule. So Atlas is a tool that helps us build this, right?
Yes.
What we're gonna use, we need concept sets. So, like right now, we want to create a cohort of new users of lisinopril with prior hypertension, right? You guys heard about the standard vocabularies, right? So, like, conditions are represented by SNOMED, drugs are like from its RX norm, classification are ATC. So we use standard vocabulary. If you're coming, which some of us do a lot, like for example, we want to reproduce a study, your paper or like your collaborator tells you that these are the set of ICD-10 that would define that. There are ways for that, right? So you can actually like go from non-standard ICD-10 to the SNOMED standard. You identify them, you put it there. We avoid using non-standard vocabularies. Reason, if you really insist on it, like for your specific reason, you might use in your institution, but we want to do network study, we want to like have like, we're here to use standard language, right? So that like so that's why we try to avoid like the whole notion as like using standardized vocabulary to do that. So that's what we do. But there are ways, like we can do this back and forth and show how it works. And we do it in Atlas. So it's like literally building a Lego in Atlas. Yeah.
So the Atlas is used to map that.
So mappings has been done, right? Athena, which I think like you saw that, like it's like where you can find like how the specific vocabularies, like it's another way to look at it, right? Like so hypertension, like, I mean, I can show it to you. Okay, give me 1 second. Athena. Okay. So, I mean, you want to say like, okay, like I want to look into condition of, I can say hypertension. Okay. So your domain is condition hypertension. So here, like you can actually look into hypertension, right? So Athena gives you like a lot. Like and a lot of you see all of them are SNOMED vocabularies. You can like, if you say that, oh, like I'm looking for a specific ICD-10, like because it gives you everything. You can limit it to all the ICD-10 codes of hypertension, like so. If that's of interest, sometimes I don't know. I'm given a code by my collaborator, a K79. It's a portal hypertension. It's a non-standard vocabulary concept. I need to use it but I need to find out like what it is. You can always like use this to say that, okay, it is mapped to portal hypertension, SNOMED concept ID of this, and this is what I'm gonna use, right? And for all of them, like what you can do here is to look into the hierarchy. It is a venous hypertension disorder portal system. And also you can see the descendant here. So that's one way to look at it. You can also do it in Atlas, but I said like if you want to like, this is a little bit different in the sense that like sometimes you want to look into the upper and higher because you can see like the mappings from other vocabularies that you might not have in your data. So, question? Any other question? Okay, should we create one together? Okay.
Let's do it.
Yeah, perfect. Yeah.
The layout.
Oh, okay. Oh, of course. So you guys all have the link, right? Yes, 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 yes. If you, yeah. Okay, it's up. If it's not up, raise your hand. If it's up, okay, everybody has it. So this is pretty much what a lot of us live by. Atlas. It's a user interface. We can do a lot of things. Do you want me to walk through like the different tabs? Okay, perfect. But technically, you can do a lot here. Like you can have like a very big brief description of your database. So like everything that comes with the Achilles report of like what do I have in my data in different database, like the amount of person observation, and that's all under data source. You can search for specific concepts. You can create your concept sets, core definition, and the rest. Please look into your screen until this starts collaborating. And the rest will be covered by Christine and others.
It's there.
Yes.
tutorial5.us-east-1.com.
Everybody on Atlas? Okay.
Okay. Let's create one cohort together. And the cohort that we wanted to create was, I'm sure this is going to work, new users of lisinopril with prior hypertension, right? So when you think about it, I want you to tell me if I want to create, like define my cohort entry of an inclusion criteria and exclusion criteria, what are the specifics? What should be my cohort entry event? New users of lisinopril. Anyone who wants to? Yes. So I can technically say that here is lisinopril, right? Use. What are my inclusion criteria? So let's look at this. New users of lisinopril with prior hypertension. Yep. Yes. Exactly. Okay. Cohort exit. Yes. Do you guys want to look into adults or not?
How many kids are on lisinopril with hypertension? Pediatricians?
So who remembers the label? When we subject with it, it's for hypertension for 6. So it was 5 years on all right. So it's adults and pediatrics. But the study can be only among adults. But that's something you can definitely specify.
So, do you guys like to specify it or keep it up?
Would you like it to be adults only?
Adults only, yes?
Put adults only.
Perfect. Adults. Okay. So one question. When I want to look into the history of hypertension, how far back do I want to look at? Any desire? A week before? 1 year.
Why? Why just a year? Why not forever?
So what are the options?
So,
1 year, 5 days?
5 days, forever, 1 year. Okay. 1 year. So why not forever and why not 5 days? Or...
Takes too long to query if you have a big database.
Love that. Love that. Why not 5 days?
Typically, why 1 year, why 5 days, why?
Sorry, Scott, I didn't hear you.
I was just going to say the look-back period, it could make a difference in your study if you have new people coming in. So if you have 10-year history on somebody, and you're comparing that to somebody who's just new into your system, looking forever has some study design consequences.
That's correct. The other thing, and also, sometimes, like if you say that I want to look within like the past week, whether the patient has this condition, it has an implication, like in terms of the number of patients that you're including compared to a year to 5 years, right? And is it like a week? Is a week, for example, long enough of a look back period to observe a specific event or not, right? So those are the questions that you have to ask yourself. You consult with your study team. What makes a good look back period? Is it 365 days? Is it 180 days? Do I want to, like, for example, there are instances that people want to have patients with no prior condition in the past 5 years, because it's very important to have like a 5 year of clean, no disease. Those are different patient population compared to 1 year of like no disease. That comes like in studying like some oncology results. Yep, David.
When you're looking at dates, are you looking at the date an event was reported, like a diagnosis was reported, or are you looking at the onset date? Does OMOP have both of those dates?
So,
Great question.
very
We have work
So when we're looking into dates, are we looking at the date that the event is recorded or the onset of disease? That's the OMAP capture onset of the disease. So special thanks to Gotham, who's really helping me today. I would be miserable with him. So remember that caricature of the patient journey? Yeah, exactly. Every time something is observed, that is captured, right? So when we see it, we capture it. So a very good example is that what is the onset of disease? I'm going to use lung cancer as an example. When do we know the disease started? It's when it's diagnosed, right?
Yeah, but you could have patients that arrive at an institution that
That's right. So if you have it, this is like a part of your, so you can create logics to get you closer to that specific time. Like if you think that like a hospital admission immediately before like a diagnosis of whatever, like MI is when it started, you can actually create that logic, right? But you need to put them together. So, okay, hypertension, we want a year prior observation. We want them to be adults. And what would be our cohort exit? At what point do we want to say that they don't belong to our cohort? Death? Any other? End of drug exposure. End of observation. So what's the difference? So end of observation, like once lisinopril exposed, always lisinopril exposed. End of drug exposure, they are in my cohort as long as they're using lisinopril. Which one do we want? Number 2? Okay. This is a drug cohort, yeah. So this is what we're going to do. We're going to create this in Atlas. And we are hoping that my computer collaborates. So let me go back. So for all of this, we need to create our concept set. New lisinopril, hypertension. Let's start with these two, right? Yeah, okay. Now I have 5 minutes to create a cohort atlas. So I'm going to tell you how I do that.
Plenty of time.
Yeah. So, concept sets. We can create a concept set. There are a couple of ways to do that. My new ways to cheat is, I love doing this recently, is you can actually look at here hypertension, or I can say hypertensive disorder, right? That's the second one that I need. Well, that's okay. Hypertensive disorder. Let's try this. There's a concept that I call hypertensive disorder. This is a cheat sheet. This is a very fast version that I've recently been really fond of. You can always import concept IDs here and then say descendant to include them immediately. One option is to go through the search. Sometimes if you have your large database, like it takes forever for this to load, so I'd like to do this. So you have an hypertensive disorders and all the descendants already included in your concept sets. Let's take a look at the hierarchy. Always look at the hierarchy to see what you're getting, because I'm not sure whether it's correct or not. Hypertensive disorder is a descendant of disorder of cardiovascular disease and cardiovascular measurement finding. None of them seems to be specific enough for hypertension, right? And then let's take a look at the descendant. The descendant seems to be all the hypertensions, like any kind of hypertension, from neonatal hypertension, hypertension crisis, secondary hypertension, and essential hypertension. At the time of your study, you have to make sure to know like whether you want to have all hypertension or not, right? So here, I'm gonna assume that for us, it doesn't matter whether it's essential hypertension or secondary hypertension or pregnancy-induced hypertension. I would like to include them all. It might be that you don't. If you don't, what you can do here is that, okay, exclude these specific ones and all the descendants from my concept list. We're gonna keep it as is. So we feel good enough about that. We have to name it. We call it, God, demo hypertension. Is there any other concept that we have to include? Let's not do it and see what happens. I need to create another concept for lisinopril. What is, let's try the normal way. Lisinopril.
What happens if you spell it wrong, Asieh?
Let's do that. Lisinopril. Completely.
Yeah.
Nothing.
Nothing. It's not that smart.
Yeah. I mean, use your friend Google.
Yes.
Misspell it, Google will tell you. You can use copy and paste. It works. So, yeah, I can find that like NDC, RX norm. Which one should I pick? Any idea? Which vocabulary? Which one? Which is my best bet? Standard for drug and OMAP? RX norm. RX norm. Okay. RX norm is the winner. Right. Classifications are purple. Non-standards are red. So the moment you see red, walk away. Okay. So I have my lisinopril with all the descendants. I am gonna say demo lisinopril. I can't stand lisinopril. Good enough. So I have two concept sets and I want to create something. Let's do it together. We're rushing against time. Okay. What was my cohort entry event?
Drug.
Yes. So a drug exposure of lisinopril, right? Import concepts. I've already created that. Demo lisinopril. What did we want these patients to have? Continuous observation for 365 days. Help me, guys. I'm running against time. This is new users of lisinopril, right? So you can always use this add attribute first exposure criteria. So these are first time in patient's history with lisinopril with at least 365 days. I feel good about it. First criteria was age 18 and above. Add demographics. Cool. Add attributes, add gender criteria. Oh, sorry, that was age. Add demographics, add age criteria, greater or equal to 18. Yes?
I have a question. What's the difference between the earliest event and when we use the first time in the history? And because our initial event is drug exposure, and if we select the earliest event, it means we use the first event for patients, and when you add the first time, what's the difference between the first time that you have added and
I'm
There is a
I'll take it offline.
diagram.
I'll give you a detailed description.
There's a diagram in the Book of Odyssey.
Yep.
I can like find you the page. So go to the Book of Odyssey. It actually has this really nice. It shows you
1 minute.
how the logic and cohort creates. It's in chapter 6.
Okay, we're running against time. They needed to have hypertension. A condition occurrence. So these people had to have at least one condition occurrence of hypertension. Yes. Within the past year, right? That's what we wanted. 300 before and 0 days after. Cool. Inclusion, exclusion, cohort exit event. It was end of drug exposure, right? End of a continuous drug exposure. So what drug were we looking at? Lisinopril. We allow for a persistent window because we see the exposure. Sometimes like people get the drug and it can be used for a while, so we can change that. Let's say that if you have an exposure, you can actually use the drug for 30 days. We call them like we allow for a maximum of 30 days between exposure and when we infer the error. No surveillance window, and then we will use the drug supply. So name your cohort. Demo 1, save, and you have a cohort. I don't know whether like you guys have to go through this concept to make sure it is, but that's a part of the exam, the process, and I specifically did not do it the way it should be for you to figure it out.
Thank you, Asieh.
You're welcome.